Did you know that in the United States, the smell of bacon ranks in the top 3 most beloved food aromas, only behind morning coffee and toasted bread? It sounds almost like a joke, but it proves one thing. Bacon isn't just food, it's a smoky ritual in American culture. So what kind of magic hides behind those crispy, fragrant slices? How can a thin strip of meat captivate an entire nation for decades? The journey of bacon begins on modern farms, where pigs are raised specifically for high-quality belly meat, then moves into factories where seasoning is injected through stainless steel needles and smoke chambers run on automated programming, before finally becoming those perfect packs of bacon neatly arranged on supermarket shelves. And today, Terran Works will take you through that entire journey to uncover why America simply cannot stop loving bacon. The bacon industry is now one of the most profitable segments of the global pork market, with an estimated value of 65 to 70 billion USD per year. The United States alone accounts for more than 35% of global revenue, making bacon not just a food, but a cultural icon. More than 70% of American adults eat bacon at least once a week. And believe it or not, the obsession is so intense that the US and Canada even designated an official National Bacon Day to honor it, a privilege granted to very few foods in history. So where does this irresistible appeal come from? Perhaps from its unmistakable aroma, the scent of bacon rising from the Maillard reaction and slow-burning wood smoke, a fragrance so addictive that people have turned it into candles, perfumes, chewing gum, and even toothpaste. Have you ever wondered, does eating a lot of bacon make you gain weight? The answer is yes, and more than you might think. Bacon is high in saturated fat, calorie-dense, and quite salty. Eating it frequently can lead to weight gain and cardiovascular issues due to its sodium and nitrite content. Today, in environmental discussions, the bacon industry also leaves a significant footprint. To produce just 1 kilogram of processed pork, the supply chain can emit more than 4 kilograms of CO2, and the smoking chilling stage alone consumes 25 to 35% of an entire plant's energy. These figures make bacon a key factor in emission-related challenges. Still, many modern facilities are deploying heat recovery systems, reducing energy use by 20 to 40% and cutting CO2 emissions by up to 25%, showing real efforts to reduce environmental impact without sacrificing bacon's appeal. And now, let's head to Tar Heel, North Carolina, widely known as the pork capital of America, where massive farms and giant processing plants supply the meat behind millions of slices of bacon every year. Before becoming the raw material for those delicious slices of bacon, pigs must go through a strict care process inside advanced, high-tech farms. To meet the standard for belly meat, the cut used to make bacon, pigs are raised for 5 to 6 months, with the goal of achieving a balanced fat-to-lean ratio and a layer of soft, white fat, ideal for curing and smoking. This is a major difference compared to regular market hogs, which are typically bred for a higher lean percentage. Inside barns that house thousands of animals, every factor, from temperature and humidity to airspeed, is controlled by a central management system. With just a single touch screen, workers can oversee the entire environment, maintaining the temperature at a steady 21 to 22 degrees Celsius and automatically adjusting fans, heat lamps, and air inlets in response to even the slightest changes. This keeps the pigs from becoming stressed, helps them eat better, and ensures uniform weight gain. Overhead, chain disc feed lines deliver feed on a preset schedule, dispensing the exact amount, down to the gram, into each trough. Below, slatted floors allow waste to drop into a separate handling area, keeping the pens clean and minimizing the risk of disease. A modern farm like this can operate anywhere from 2,500 to over 10,000 pigs within a single system, requiring only a small technical team for supervision. Thanks to this high level of automation, modern pig farms can save thousands of labor hours each year, reduce manual errors, and maintain consistent growth across the entire herd. This forms the essential foundation that allows processing plants to secure a stable, standardized supply of pork for large-scale bacon production lines. After reaching market weight, pigs are transported to the processing plant. But moving a herd from one point to another is far from as simple as loading them onto a truck and driving away. It is an optimization challenge that requires balancing cost, speed, and animal welfare at the same time. Among all transport methods today, trucks remain the most common option. Their compartments are built with perforated steel panels for natural airflow, the floors are covered with sawdust to absorb moisture and improve traction, and the waste drain openings below help reduce slipping as pigs move around. Trucks are flexible, low cost, and can access individual farms directly. However, they are entirely dependent on weather conditions. On hot days, pigs must be misted with water continuously to prevent heat buildup and reduce stress throughout the trip. For that reason, truck transport is only optimal for short hauls, lasting from a few hours up to about a day. When pigs need to be moved at massive scale, ships become the intercontinental highways of the pork industry. Their main advantage lies in the extremely low cost per animal and the ability to carry tens of thousands of pigs in a single voyage. Even so, the multi-week travel time and weather risks make this method better suited for markets that can tolerate long delivery windows. Did you know that in some cases, pigs are even transported by airplane? It might sound unbelievable, but this is actually the highest tier of modern livestock logistics. Pigs are placed in specialized wooden crates with ventilation openings and are secured with mesh restraints to prevent shifting during takeoff and landing. Thanks to this setup, air transport can reduce travel time from weeks to just a few hours, offering unmatched speed and survival rates. However, compared to trucks or ships, the cost of air transport can be 5 to 10 times higher. Combined with strict quarantine requirements and limited cargo capacity, this method is reserved only for the most exceptional shipments, typically high-value breeding pigs or urgent orders that must be delivered immediately. After being transported to the processing plant, the pigs enter a strict handling sequence where every step is standardized to ensure food safety and meat quality for the bacon industry. The pigs are anesthetized, lifted onto an automated overhead rail system, and bled quickly to maintain an attractive color and ensure stability during storage. Next, the carcasses are immersed in a hot water scalding tank to soften the hair follicles, then moved through high-capacity dehairing machines. The skin is then singed with gas torches to remove any remaining hair and to sanitize the surface. Once the body is clean, the automated evisceration line takes over. The internal organs are removed and sorted, while the carcass is split in half using specialized cutting equipment, revealing the belly, the primary raw material for bacon. Finally, the split carcasses pass through inspection, high-pressure washing, and initial chilling before being transferred to the trimming area. The entire process is designed to produce a clean, uniform carcass that meets microbiological standards, fully ready for the next stage of bacon production. After the carcass is cleaned and pre-chilled, the pork belly is separated to begin the trimming stage, the foundation that determines the quality of the final bacon. Automated cutters use steel blades with precision down to 1 to 2 millimeters to remove the rib bones, adjust the belly thickness to about 3.55 centimeters, and optimize the fat-to-lean ratio to the ideal 50-50 balance. Each pork belly is then scanned by an AI camera system to assess color, firmness, and moisture levels before moving on to the curing area. Have you ever wondered why bacon has a flavor that the whole world seems obsessed with? The secret lies in the curing stage, where each strip of pork belly is essentially reprogrammed with flavor using second-by-second precision. First, the pork bellies go into a 16 to 48 needle injector, with each needle pumping a curing solution of salt, sugar, nitrites, and spices at a steady rate, penetrating deep into every layer of tissue. The amount of solution is tightly controlled at 10 to 12% of the meat's weight, ensuring a balanced, salty, sweet, smoky profile without making the meat bland or overly salty. Next, the pieces are transferred into a vacuum tumbler that slowly rotates for 45 to 120 minutes. Under mechanical motion and reduced pressure, surface proteins open up, allowing the seasoning to bind evenly and creating the characteristic adhesion needed for forming uniform bacon blocks. At this point, the pork belly is ready to enter the smokehouse, where its signature aroma is perfected. After the curing has fully penetrated the meat, the pork belly enters one of the most critical stages, smoking. In modern plants, this process no longer relies on manual experience, but is controlled by automated smokehouses capable of precise programming down to each degree of humidity and each degree Celsius. The pork bellies are hung on stainless steel racks and loaded into multi-tier smokehouses. Here, the smoke is generated from compressed oak or apple wood, burned at a stable 320 to 350 degrees to produce clean smoke with minimal impurities. Inside the chamber, the meat goes through 3 phases: drying, smoking, and cooking, with temperatures maintained between 55 to 70 degrees Celsius and humidity controlled at 60 to 80%. Temperature and humidity sensors continuously monitor and automatically adjust the smoke flow, ensuring every batch of bacon achieves its signature pink-bronze color and uniform smoky flavor. This automated system not only guarantees consistent quality, but also reduces energy consumption by 20 to 40% compared to traditional smokehouses. Have you ever wondered why the bacon slices in supermarkets are always flat, square, and perfectly uniform? The secret lies in the forming and pressing stage. Right after smoking, the pork bellies are placed into stainless steel molds and compressed under 2 to 6 bar of pressure in a chilled environment of 0 to 4 degrees. Force and temperature sensors ensure that the pressure is distributed precisely, transforming the soft belly into a firm, uniform block with exact dimensions, perfectly optimized for the next step, ultra-thin slicing. After being pressed into shape, the pork belly reaches the ideal firmness for the high-speed slicing machine. Here, the entire process is controlled by rotating or linear blades operating at 1,000–3,000 RPM, ensuring each slice is only 0.8 to 1.5 millimeters thin, while maintaining a clean, continuous fat-to-lean structure. An AI camera system and thickness sensors measure every slice in real time, automatically adjusting blade speed and compression force to eliminate variation. As a result, each line can produce 200 to 600 slices per minute, all uniform and precise, with no tearing or deformation. The bacon slices are then arranged in one of 2 formats: shingle, overlapping, or stack, neatly stacked. This entire process ensures that every slice of bacon you see in the supermarket is not only visually perfect, but also consistently shaped. A key factor that determines crispiness, edge browning, and even flavor when cooked on a pan. After the bacon is sliced and portioned, it enters the packaging stage, the final step before becoming a commercial product. The slices move along the conveyor and pass through a weight sorting system equipped with load cell sensors accurate to slice 1 gram, ensuring each tray meets the exact 180 grams, 250 grams, or 500 grams standard. Next, automated robotic arms place the shingle or stack arrangements into plastic trays. The trays then enter a vacuum modified atmosphere packaging MAP machine. Here, oxygen is reduced to below 1%, followed by an injection of a CO2N2 mix to preserve the bacon's pink color and extend its shelf life to 20 to 40 days. Finally, a heat sealing unit closes the multi-layer PE film at 160 degrees Celsius. A laser printer marks the date, and the product passes through a metal detector for safety assurance. All approved trays are then boxed and moved into a 0 to 4 degrees Celsius cold storage area, ready for distribution. From the high-tech farms of North Carolina to the automated production lines inside modern factories, The journey of a slice of bacon is far more complex and precise than its crispy appearance suggests. Every strip you see on a supermarket shelf is the result of hundreds of controlled variables: temperature, humidity, pressure, blade speed, along with continuous efforts to reduce environmental impact throughout the entire supply chain. And that is why bacon has transcended the boundaries of a simple food. It has become a fusion of science, engineering, and the timeless human passion for flavor.